Today we're going to be talking about Lesson 3 in Chapter 5, Solving Systems of Equation by Elimination. So this is the third way that we can solve a system of equations. So here are the 4 steps. The first step is multiply, if needed, one or both of the equations by a constant, so at least one pair of like terms has the same or opposite coefficients. So this is telling us that we have to get either the coefficients of the x or the coefficients of the y to be the same or the opposite. So like either both positives, both negatives, or a positive and negative of the same exact coefficient. Step 2, we're going to add or subtract the equations to eliminate one of the variables. So this is where that term elimination comes. We're going to take it away. We're going to get rid of it. Step 3, solve the resulting equation for the remaining variable, and then substitute that value back into the original equation above to solve for the other variable. So let's take a look at what a few of these look like. So here for the first one, solve the system using elimination. So for number 1, we can see that we have 2x and 4x. These are not the same, nor are they opposite. But we have negative y and positive y. We know that negative y and positive y will cancel each other out or eliminate. Then we can add or combine terms through the rest of the equations. So 2x and 4x makes 6x. 9 and 21 makes 30. So we have 6x equals 30. And we can solve for x by dividing by 6 on both sides. So we know that x equals 5. We can then take this value back into one of our equations. So 2x when x is 5 minus y equals 9. So 2 times 5 is 10. We can subtract 10 on both sides to find that negative y equals negative 1. And we can divide by negative 1 on both sides to end up with a positive variable. So y equals positive 1. Now we can write these values in an ordered pair for the solution of the system. And then that would be the final step there. You can go back and check your work, which is recommended, but I'm not going to show you how to do that here. We've talked about that in previous lessons. So now with number 2, we can do the same thing. Go ahead and give number 2 a shot right now. On number 2, we can see that we have negative 5x and 5x and 2y and y. We can see here that these two, negative 5x and 5x, will eliminate. They'll cancel. So we can combine our remaining pieces of the equations. So 2y plus y is 3y. 13 minus 1 is 12. And when we solve for y, we find that y equals 4. Now again, we can take that back up and plug it back in. So we have negative 5x plus 2 times 4 equals 13. We know that 2 times 4 is 8. We can find that negative 5x equals 5. So x equals negative 1. Again, we can take these two values and write them as an ordered pair for the solution of the equation. Now, when you look at number 3, we see that we have 3x and 7x and 4y and 4y. So none of them are opposite of each other, but we have two that are the same. In order to get one of these to cancel out, we need to make one of these a negative. So what we can do is we can multiply everything in the equation by a negative 1 to change the signs. So this is like the distributive property here. So negative 1 times 3x is negative 3x. Negative 1 times 4y is negative 4y. Negative 1 times negative 6 is positive 6. Now we can use the original second equation and the new first equation to solve for our system. We can now see that 4y and negative 4y will eliminate. 7x minus 3x is 4x. Negative 14 plus 6 is negative 8. So we know that x equals negative 2. Now, when we plug this in, we need to go back to one of the original equations. So if I take 3x when x is negative 2 plus 4y equals negative 6, we know that 3 times negative 2 is negative 6. Add 6 to both sides to find out that 4y is 0. So y is 0. So here we can have our ordered pair of negative 2, 0. In the next three, you're going to notice that they do not have the same coefficients on either variable. So we're going to be practicing that multiplication step, that step 1, to try to get them to have the same coefficient. So if we look here at number 4, so we either need to get the x's to be the same coefficient or the y's to be the same coefficient. It doesn't particularly matter. I usually try to choose the one that either they already have opposite signs or the one that seems to be the easiest to find, the common coefficient. So in this one, I know that if I multiply 3x by 2, I'm going to get 6x. But I need it to be a negative 6x. So I'm going to multiply this entire equation by negative 2. So this looks like just like the previous one where we multiplied by negative 1 to change our sign. Here we're going to multiply everything in the parentheses by negative 2. So negative 2 times 3x is negative 6x. Negative 2 times y is negative 2y. Negative 2 times 11 is negative 22. We can now use our second equation and our new first equation to simplify and solve for the variable. So 6x minus 6x eliminates. 3y minus 2y is y, or 1y. 24 take away 22 is 2. Again, we can take this back to the first equation. So 3x plus 2 equals 11. To find that 3x is 9, which makes x 3. So our ordered pair would be 3, 2. Again, if we graphed these two equations, this is the point where those two lines would meet or cross. Now, with number 4, we can see that there's probably no easy, just jump out one that looks good. We know that we can't multiply 2 by anything, even, by a whole number to get to 5. So we might want to look at the x's. We can see that these already have opposite signs. So to get negative x to be negative 4x, I have to multiply everything by 4. So 4 times negative x is negative 4x. 4 times negative 2y is negative 8y, and 4 times 8 is 32. Now we're going to rewrite the top equation here so they can be right next to each other. Negative 4x plus 4x cancels. Negative 8y minus 5y, they have the same sign, so we add and keep that sign. 32 minus 19 is 13. So we can go ahead and solve for the variable to find that y is equal to negative 1. Going back to that original equation, 4x minus 5 times negative 1 equals negative 19. Negative 5 times negative 1 is positive 5. And we can solve for x to find that x equals negative 6. Go ahead and give number 6 a try right now on your own. All right, now probably the easiest thing to do with number 6 is going to be to multiply everything in the second equation by negative 5. That'll get the y's to cancel each other out. So when we do this, we can say negative 5 times y is negative 5y. Negative 5 times negative 2x is positive 10x. Negative 5 times 3 is negative 15. Now, when we rewrite our first equation here, we have 5y equals. Now I'm going to rewrite this so that way my terms match up, my like terms. So negative 5x plus 15. We can see that my negative 5y and 5y cancel. Since that's the only thing on the left side of the equal sign, then we're going to leave a 0 here as a placeholder. 10x minus 5x is 5x. Negative 15 plus 15 cancels or makes a 0. We can solve for x by dividing by 5 on both sides to find that x is 0. Now, when we plug this back into that original equation, 5y equals 15 minus 5 times 0. We know that 5 times 0 is 0, so 5y equals 15. To find that y is 3. So again, our ordered pair here is 0, 3.